What are NER evaluation metrics in NLP? Imagine trying to teach a computer to read and understand news articles, emails, or social media posts. How do we know if it's doing a good job? That's where evaluation metrics come into play. They help us measure how well a named entity recognition system is performing. Named entity recognition is a part of natural language processing that finds and classifies important pieces of information like names of people, places, organizations, dates, and more. When building these systems with deep learning and specialized artificial intelligence, it's essential to have ways to see if they're accurate. The three main metrics used are precision, recall, and the F1 score. Precision tells us how many of the entities the system predicted are actually correct. For example, if the system says there are 10 names of people in a paragraph but only 6 are right, the precision is 6 out of 10. High precision means fewer false positives, so the system isn't making many mistakes by labeling things incorrectly. Recall measures how many of the true entities in the text the system actually finds. If there are 10 names and the system finds 8, the recall is 8 out of 10. High recall means the system isn't missing many important entities, reducing false negatives. The F1 score combines these two measures into one number by calculating their harmonic mean. It helps us see the balance between precision and recall. If a system scores high on the F1 score, it's doing a good job of both finding the right entities and not making too many mistakes. Evaluation can happen at different levels. Token-level evaluation looks at each individual word to see if it was labeled correctly. But this might not tell us if the entire entity span was identified properly. Entity-level evaluation considers the whole name or phrase as a single unit. For example, correctly identifying New York City as a location is more meaningful than just labeling New as a location and York as something else. When testing a NER system, we compare its predictions to a set of correct answers, called ground truth. We count true positives when the system gets an entity right, false positives when it predicts something that isn't correct, and false negatives when it misses an entity. These counts help us calculate the metrics. Using these metrics is vital because it shows how well the model will perform on new and seen data. For example, in applications like chatbots, content moderation, or information extraction, accuracy matters a lot. Developers often test their models on separate data sets to check if the system can generalize beyond the training data. This process helps improve the model and make sure it works reliably in real-world situations. In the world of artificial intelligence and machine learning, understanding these evaluation metrics guides the development of better natural language processing tools. Whether it's a system like ChatGPT that needs to understand and generate language accurately or productivity plugins that analyze text, these metrics help ensure the models are doing their job well. They are the tools that tell us if our systems are on the right track or if they need more fine-tuning. So, in simple terms, precision, recall, and the F1 score are the essential yardsticks for measuring how good a named entity recognition system is. They help us see where the system excels and where it might need improvement, making sure AI tools can understand human language more accurately every day.